Kia ora team and welcome to another online tutorial. Today we're going to be talking about calculating speed, or as we call it in level 1 mechanics, velocity. We're going to use our understanding of mathematics and the equation provided, v equals d over t, to see how we can use information to also rearrange that equation and find distance and time. I would like to start this video by talking about both speed and velocity and the similarities and difference between the two. In level 1 mechanics, we use these interchangeably. Speed being how fast an object is going, velocity being how fast an object is going in a certain or given direction. Now, we can define the equation for velocity, or give the equation for velocity, as v equals d over t, okay, where v is our velocity measured in meters per second, which can be written as ms-1. Okay. D is our distance in meters, and t is our time. If we look at the equation, we can see that the unit provided for velocity, meters per second, makes sense to us because we're dividing distance, which is measured in meters, by time, which is measured in seconds, meters per second. Let's imagine our rocket flying around, etc. Okay, we're going to use the example. A rocket travels 800 meters in 10 seconds. Okay. Calculate its velocity. All right. So we're going to write down our equation whenever we do any kind of calculation as our first step. So we'll write out v equals d over t, and we're simply going to substitute. Okay, so we're going to look for information that we have in the provided question and put it into our equation. So we can see we're looking for a distance and a time. We can see we've been provided a distance and a time. So I'm going to put that into my equation. V equals my distance, 800 meters, over my time, 10 seconds. And I can calculate my velocity as 80 meters per second. Okay. A reminder that ms-1 is the same as m over s. So let's look at how we can use the formula, or rearranging the formula, to calculate distance or time. Okay. So we're going to imagine that we've been provided a velocity and a distance. Okay. So we would look here and say, okay, cool, our rocket has been traveling at a velocity of 80 meters a second for 10 seconds. How far has it traveled? All right, and I'm not going to rewrite that question, but I'm just going to give the information down below. I'll say v equals 80 meters a second, okay, and t equals 10 seconds. All right, I'm going to start out with my equation. V equals d over t. Okay, now we're looking for distance in this particular equation, so we're going to make d the subject of our equation. I see that it's d over t, so I want to times both sides by t, okay, which would cancel my t on the right-hand side of the equation, leaving me with just distance, which is what we want. So I'll get v times t equals distance. Okay. If I plug in the information, I'll get 800 meters. Okay. Showing that it's in line with our calculations above. What if we're looking for time? Okay. If we're provided with the velocity and the distance, okay, v equals 80 meters a second and d equals 800 meters, we're going to go through the same steps. I would write out the equation v equals d over t. Okay, I want to make t the subject of my equation this time because that's what we're looking for. All right, but it's underneath the d, which makes it a little bit harder to get rid of. Okay, so what I'm going to do first is I'm going to times again both sides by t, moving it to the left-hand side of the equation, and I would get v times t equals d. all right? But a reminder that I still want to make t the subject, so I'm going to divide both sides by v, okay, which will get rid of the v on the left-hand side of the equation and give us t equals d over v, all right? We plug that in and we would get 10 seconds, okay? You can see that using the calculations, we've calculated the correct answer each time. All we're doing is changing the equation to suit us for what we're looking for, okay? Remembering that whatever you do to one side of the equation, you have to do to the other, and we can use our understanding of that to calculate what we want. If you struggle with rearranging equations, okay, that's all right. We have another method up the top, which some refer to as the magic triangle. Now, I'm not personally a fan of the triangle because I think it doesn't develop your math skills for later years and later applications in science. But I'm going to show you how we're going to use it, okay? We're going to imagine that if these letters are next to each other, that means times, and if it's above each other, that means divide, okay? So you're going to cover whatever you're looking for in the triangle. So if I'm looking for velocity, okay, I would cover my v, usually with a thumb, and I can see that my v equals d over t, right, as we have in our normal equation. Next time, we're going to look for distance. So I'm going to cover distance, and I'll say that my distance equals velocity times time, okay, which we have calculated from rearranging the equation, and we know is going to work. If we're looking for time, we do the same thing. We cover t, and we can see t equals d over v, okay, which we calculated when rearranging the equations, and we would get our answer. So team, we've covered how to calculate speed and velocity, okay, what they are and that we use them interchangeably, how to use our equation to calculate velocity, and how to rearrange these equations, okay, so that we can calculate not just velocity, but also distance and time in a given scenario. Okay. Hopefully this helps, team. Hopefully it helps you get out there and get into some mechanics. Good luck.